Welcome to NPTEL course on power system protection. We are continuing with line differential protection. In this lecture, our focus will be on transmission line or any feeder having tapped lines. Differential protection that includes also a transformer or so, and the end we will go for the phase comparison protection, which also has the communication support and so. So, continuing with that, in the last class we talk about 87L, the line differential protection with current signals from both the ends. Essentially, for a line feeder we need communication system, we need breakers at both the ends for an interconnected system. In addition, these breakers, because they are remotely placed, we require differential relay individually at these two locations also. As compared to transformer, note here that in transformer we require essentially one relay, and if it is interconnected system, breakers from both the ends, and if it is a radial system, breaker at one end only. In this case, because they are large apart, so we require, you can say that for this breaker also another relay. Furthermore, we say, you can say that that the trip decision and all these things, what we say the percentage by differential relay, which we have already discussed for the line protection also using the current information. The communication link is the backbone that decides the speed of operation of the relay. Now, this side relay sends current information to the other end, let us say the phasors, both real and imaginary part. In that case, this end receives and then processes it for a decision, either using ping pong or Eric B signal through the GPS and so. Now, thereby the communication delay, associated delay, that decides that at what time you can say that the corresponding differential protection will go for a processing. Say in one case, on the percentage biased differential relay perspective, it may decide every 5 millisecond, every 3 millisecond, every 2 millisecond or so go for this processing depending upon the communication link capacity. In case of differential relay for transformer protection, that is localized, and therefore, you can say that that can be pretty high speed, whereas the speed of operation of the differential relay here is decided by the capability of the communication link. Now, let us go to the other applications of the line differential protection. First one, differential protection of feeder with tapped lines. So, here this is the feeder or the line, and we have a tapped line. It may be load, it may be today's renewable generation and so. Now, the benefit here is that we do not require a substation, you may not require also a breaker here also. In that case, this additional current, if we apply the KCL here, earlier we are talking about L side current and R side current. Now, there is additional current here. So, therefore, the differential relay must take into account that. Now, if you have communication information from all these, fine, you can use the corresponding KCL, and you can say that each you can say that relay can decide very efficiently. But sometimes the communication link may not be available, then what is the in case of there is no provision for the, you can say that communication link and so, then how to handle that, that is what. And at times also there may be a failure of communication, then how the corresponding relay will handle that situation and so. So, we say, you can say that the connection may be applied to with or without breakers. At this point, the protection concept must be individually adapted to the different situations. It is one, you can say that tapped line, there can be multiple tapped line also and so. what is being done is that a non-directional distance protections covering 120%, like you see here, you can say that from L end, this pink color you can say that covers 120%, and from the R end the green color takes 120%. Such a provision is there to initiate, you can say that the corresponding 87 L, agree, to trigger the 87 L. Yes, there is a fall in the line also. This we can say that makes, you can say, advantageous to the system, you can say that, considering that the corresponding impedance of this path, and so you can say that is much higher, that is that the impedance of the transformer becomes much higher also. Now, how the corresponding settings in such a tape line is being considered? There are the pickup setting, and so you can say that we will elaborate on that. For the application of this feeder differential protection, the pickup threshold must be above the maximum sum total current of the applied tape loads. To note, if there is no current information available at this end or this end, then the corresponding differential current for this load current will be, must be considered greater than the tapped current. That is essentially because that information is not available here. So, if you have multiple, you can say that tap and all these things, then also you can say that the corresponding maximum, you can say that tapped current must be included in the pickup setting also. Now, what will happen that whenever you switch on, you can say that the corresponding system at from one end because of some maintenance, and so then at that time you can say the inrush current will flow. This inrush current you can say that is very large amount, 5 times and so also at times. So, that current you can say that will flow through this one, and we know you can say that in line differential we do not bother about the inrush, as we have already discussed in the last class, unlike that of a transformer protection. So, but here you can say that there is a transformer associated which will result in inrush current seen from this end and also from this end. So, therefore, the inrush blocking is not generally available with conventional relays, but the inrush current transform in the event of that. So, therefore, the point is that can you address that in the pickup level of the consider differential protection, that is the consideration. The maximum short circuit current during a fault on the secondary side of a state transformer must be considered. What do you mean to say that the fault here, you can say that the maximum fault current, you can say that for just after the consider transformer, that must be considered also, you can say that in the for the differential, you can say that perspective, and so in the while setting the relay. We will go to that example in the subsequent slide also. If signal communication is available, the differential protection on the feeder may be blocked during the critical condition. What do you mean to say that? If there is signal available, so if the fault happens to be beyond the transformer, then in the load side of the transformer, then these 87 L both you can say should be blocked. Okay? That is what we like to say. So, that will you can say that avoid unnecessary tripping of the 87 L and make you can say more sensitive also. Now, let us go to an example, it will clarify a better way you can say that what we will intend to address here. So, here you can say that we have the grid connections, we have a feeder here, and at different points of the feeder we have tapes connected via transformers, 20 MVA, 5 MVA, 10 MVA transformers are connected, 3 transformers are connected to this you can say that through tape for the 2 tape lines which are feeding to different loads. We have short circuit capacity of this side grid and this side grid, all data given, line length of 6 km, 10 km or 5 km and another 5 km available here, 110 kV system, total length is 26 km feeder. How this corresponding differential protection for the feeder will be accomplished. So, what we have just discussed earlier. How much you can say that will be the pickup setting? Can increase the pickup sensitivity be achieved by applying distance zone release? So, what we say that can 21 or the distance relay will supplement this 87 L in a better way, that 120% setting what we are telling about, we will look into that perspective. So, now we go you can say that to the solution for this network, this system, this feeder protection in the presence of number of tapes you can say they are talking about. Now, what is being seen here that these line feeder you can say that are having, you can say that having smaller lengths. So, one straightforward you can say that comparison on the impedances of the line of the feeder as compared to the impedance of, you can say that of the transformers. So, when you see, you can say that the largest, you can say that capacity transformer, that will have smaller, you can say that impedance as compared to the other transformer. So, this is 20 MVA. So, for that you can say that the corresponding transformer impedance is happens to be 73 ohm referred to the 110 kV side, line side. This is having 194 ohm and this is having 120 ohm referred to the all 110 kV side. So, this means that you can say that the larger, you can say that capacity transformer is having 73 ohm as compared to the point sequence impedance of the transmission line. This is, you can say that much higher. So, the transmission line is having 26 kilometer and then you can say that we have XL, you can say that is 0.5 ohm per kilometer, 26 into 0.5 is the corresponding point sequence impedance of the line. So, that you can say that gives you can say that around that gives you can say that 13 you can say that ohm or so. So, as compared to that the corresponding transformer impedance is much higher and so. The infeeds and all these things also, the associated infeeds and all these things also, that also you can say that higher impedance. So, combinedly as compared to the, you can say that the feeder impedance in general. So, with that condition you can say that we will see, you can say that how we will proceed for the, you can say that the corresponding further calculation. Now, let us say you can say that we do not have distance relay support to consider that for the line differential, then what, and if we have a distance relay support, then what, agree. Now, the largest error current differential for the differential protection results during a short circuit behind the 20 AVF transformer. Load is one part, true, but if a fault happens to be beyond the transformer, that fault current will be much significant. So, we say that the capacity having largest will having a smaller impedance related to the other transformer, and we create a 3-phase fault beyond the transformer, then we talk about, you can say that the corresponding fault current will be more significant beyond the you can say that the transformers in the tap lines. So, therefore, we consider the highest you can say that transformer capacity. So, that the corresponding fault just beyond the transformer becomes equals to IF equals to voltage level. We are referring to all to the high voltage level 110 kV to the feeder side, 110 by root 3 per phase, and then you can say that we have 73 ohm you can say that refer to the 110 volt side. So, that gives us 870 ampere you can say that for the 3-phase fault at just beyond the transformer refer to feeder side or the 110 kV side. Taking a you can say that factor of security margin of 30% extra. So, 1.3 into 870 gives you 1130 ampere. You can take any other you can say margin depending upon the choice. So, this is about you can say that the pickup setting you can say that for this threshold, this pickup in the percentage bias differential for the feeder protection 87L, this pickup setting should be accordingly 1130 ampere in terms of that perspective, agree. So, this is you can say that much higher than the total load of the system, and so that is what the pickup current should be satisfied in terms of that. Now, with the distance relay, suppose this you can say that the distance relay means it takes voltage information. So, if this corresponding relay you can say that there is voltage signal is available, and then we have a distance relay, and you can say that the distance relay zone with 20% over is 120% zone 2 kind of thing. For the considered feeder will be set to consider ZR equals to 1.2, 0.5, 26, that gives you 16.9 ohm. But this 16.9 ohm is still much smaller than the 73 ohm, that we can say that this you can say that impedance of this transformer refer to the 110 kV sides. So, therefore, you can say that I mean to say that a fault beyond the transformer will never be seen by consider the corresponding relay, and that means that you can say that they will see in this line. So, what will happen that you can say that even if we take you can say that not 16.9, you can take higher value also, absolutely no problem. What we consider this corresponding distance relay does is that it supplements the 87L to be considered to be initiated, and 87L on based on you can say that its percentage by differential relay can make a decision whether the fault is internal or not, and that is where this 21 or the distance relay with 120% setting, and so helps in, you can say that deciding the corresponding feeder protection in such a tapped, you can say that arrangement. Now, there is another, you can say that about that, if you so you can say energize from one end, or so you can say that inrush current will flow. So, what is the inrush current level, that we like to see. So, during the feeder energization, you can say that from one side, all you can say that, let us say in this example, all 3 transformers will be switched on at a time. So, that means that all will be having inrush current. Let us say what situation. So, the corresponding at inrush situation, a current will flow, and that will be summation of I of all the 3 currents, inrush current. So, what is the corresponding impedance seen by the distance relay? So, that is what our interest. So, Z inrush from any end side. So, V by root 3, 110 by root 3 in this case, and then you can say that we assume that the corresponding inrush is a fundamental component of 50% maximum for that maximum inrush situation, and summation of, you can say that the inrush current in the 3 branches. So, that is what you can say that we talk about here, the IST, the total current flows in the transformer during the energization, and all the 3 perspective. For calculation, it was assumed that the protected only that the 50% fundamental, that is what typically you can say that happens to be there in case of inrush current also. We have a large amount of other harmonics component, particularly of second harmonic. So, going to that, let us say you can consider that the inrush current in each, you can say that tapped line is 5 times of the nominal current of that branch. The nominal current corresponds to 20 MVA, here it corresponds to 5 MVA, and here it corresponds to 10 MVA. So, therefore, what is that the total sum of, you can say that the inrush current, which is say 5 times of the nominal current, first transformer, second transformer, third transformer. So, that results in, you can say that the total current to be during inrush is expected to be 0.918 kilo ampere, 918 ampere. Thus, the Z during the inrush switching, you can say that the corresponding 21, you can say that at one end the distance relay will see, you can say that V 110 by root 3 upon the corresponding summation of this current with a consideration of 50% of the considered fundamental of that current. So, that gives you consider 138 ohm. So, what it says? We have calculated, you can say that 120% also gives us some 16.9 or 9 ohm or so, but here you can say that during inrush situation also the corresponding impedance you can say that seen by this side or that side, you can say that switching will result in 138 ohm, which is much higher even than the corresponding 73 ohm of the transformer. So, that you can say it means that for an internal fault, you can say that this corresponding impedance seen by the 21 will be much smaller than that of the considered during inrush or fault beyond the transformers. So, this major impedance is therefore far enough outside the intended setting of, you can say that ZR, even if we set up very large value of 50 ohm or so, and that will not get a problem. So, the overreaching zone in this example is therefore well suited for release of the feeder differential protection. So, it means that it supplements the corresponding differential protection in a better way, and that is you can say that we like to say here that for tapped line you can say that if the distance relay supplements the 87L, that become a better performing differential protection for that perspective. So, that it become sensitive and reliable also. Now, I will go to the second example on line differential protections that includes transformers. So, what we like to say here that we have a transformer connected by a feeder or cable, small line length, and then we have a bus here and here a bus here. So, like in case of in general in transformer case, you can say that we only earlier we are considering only the transformer. Now, here a transformer is, you can say that is connected to a overhead line or cable, maybe small length, and then we have, you can say that. So, what you can say that we like to say that we will have, you can say that combined protection of this one, a differential protection. If you go for, you can say the individual, you can say that will be too expensive also. So, how you can say the joint, you can say that cable or the overhead line and the transformer can be protected by the differential arrangement, that is what the issue here in this case. And again we are talking about the percentage bias to consider this, and then we have you can say that this local end and the remote end you can say that IL signal and iron signal, and then you can say that we are you can say that have just like a line differential protections, breaker here, breaker this end, and we have individual 87 from this both the perspective and so. But mind that what will happen, because it includes you can say that transfer in series. So, whenever we energize the corresponding from any one end, there will be inrush current. So, inrush will be problem, and then you can say that the other you can say that issue of you can say that there will be a transformation of you can say that current, suppose fault happens to be there, the corresponding current here. So, those kind of you can say that angle transformation, angle phase shifting you can say that will happen just like a transformer. So, therefore, even we have a feeder here. So, line differential protection only seems like that is not adequate because of the presence of transformer. So, what are the things to be taken care? We like to see here. The differential protection for this application must include the other features of the transformer, the turns ratio transformation, the vector group adaptation, that matrix we remember for the phase you can say that shifting issue with both these sides CT is connected in star grounded, that is what the practice today, and then the corresponding inrush blocking, over excitation and so, those you can say that issue must be considered, must be inclusive. The zero sequence elimination also is essential, because when it is star and delta you can say that, and so therefore, delta side you can say a line current will not be having zero sequence current, whether you can say star grounded side will be having zero sequence current also. So, all these you can say that features must be there for such a protection, that to mean to say that this 87 will be a nothing but a just like a transformer protection, but that includes a portion of the cable overhead line also. So, that is why these are the considered steps we follow, you can say that to apply the corresponding this combined protection of cable and cable or overhead line and the transformer. So, continuing that, the protected object must be allowed to extend over larger distances, which means that the major value transferal must have the protection. So, we require essentially cable, I am saying that communication here, unlike a transformer here, unlike a transformer here. Typically, you can say that this length overhead cable, and so you can say that can be around 1 kilometer or like that, and so smaller than that. The normal feeder protection must be considered having applied to the required ratio compensation, proper CT connection, because you see here CT you can say that turns ratio will be different, unlike for a line feeder protection, and so inrush blocking and communication are the added requirement for such an arrangement. Now, here also you can say that what you can say that we will say that can you include you can say that distance-less supplementation, like what we talk about in case of the earlier you can say that application also. Sometimes you can say that a differential is integrated with distance zones, and in that case you can say that under reaching zone would be graded. You can say that what is being done here, you see here in earlier example you are talking about overreaching, now you are talking about underreaching kind of things, and what is being done, this would provide fast protection even when signal transmission fails in case of communication failure also, and that is you can say that the requirement in case of that. So, what is being done, you can say that the corresponding impedance setting from this side, this one goes to you can say that one winding of the transformer, and from this one it ends up with the one winding of the transformer. So, thereby you can say that it ensures that you can say that the corresponding, as already known, the corresponding impedance of the transformer is larger. So, that also indicates that whether it is inside the transformer or not, and that you can say that is the advantage we can exploit. You can say that if the corresponding 87 is supplemented by the distance-less perspective. However, we require voltage signal in terms of that also. These kind of you can say that arrangement also in case of communication failure and so is supplemented by overcurrent protection 50 or 51, you can say that on both sides also. Mean to say that today's you can say that relays are pretty powerful, and they can integrate you can say that different you can say that principles altogether depending upon the availability of signal, and they can make a combined you can say that a decision for the reliable operation of the protection scheme. Now, I will go to another you can say that the third aspect of this you can say that lecture on phase comparison protection. So, how phase can be compared and in a communication system environment. we will again going to the same 2 bus systems L and R, and then we have you can say that the corresponding communication systems, and this is 87 PC for the phase comparison perspective, and how we can say that we can apply the concept you can say that to the phase can be compared, and then a decision on internal fall or external fall can be ensured you can say that we like to see. Here unlike the corresponding you can say that phase value or the corresponding signal value may be transmitted from one end to other end in a feeder protections, only the corresponding concept you can say D is here, the phase is compared in this perspective and so. So, what is being done here you can say that the line phase comparison protection schemes compare the phase angle of the currents at the 2 terminals. For internal faults the line terminal currents are almost in phase, and for external faults the terminal currents are 180 degree out of phase. So, the CT is as connected in the differential protection arrangement we see. Now, let us come to consider to the internal fault first, and then we will discuss about the external fault. Internal fault means fault inside this line, and external fault is maybe beyond R or beyond L, to the left of you can say beyond L. So, for the internal fault case the local current you can say that this becomes this current. What it do you can say that we make you can say that the corresponding signal you can say that to be like this at the 0 crossing we start, and we will make a delay of LD, and what the LD means we will talk about later on. Similarly, you can say that the corresponding at remote end the corresponding signal sinusoidal signal is like this for the internal fault also because of the proper CT connection, and then you can say that you make the square wave you can say that here, that again you can say that is related to the corresponding 0 crossing point, and then only in the positive half, agree. So, that is what the positive half cycle is being applied in this arrangement what we are showing in this diagram, phase comparison diagram, and then you can say that we make the ending of this you can say that these 2 signals the SL and SR which are being transmitted. So, this L end receives you can say that the SR signal from this end, and the R end you can say receive the SL signals this square wave, agree. And then you can say that this nothing but tells about you can say the positive half you can say that, and now you can say that the overlapping region you can say that is being there. So, that of the SL and SR, and the overlapping you can say that happens to be this portion. So, that means that this overlapping portion you can say that indicates indicates the corresponding you can say that phase information of this signal and this signal. So, therefore, the corresponding time information that how much time in the corresponding square wave remains, overlapping region, coincidence region remains, that is indicative of the phase angle you can say that relation of IL and IR, and then you can say that a trip decision can be issued. Now, come to the external fault case, if this is IL, this becomes the IR for external case because of the proper CT connection, and now the corresponding you can say that square wave generation considering the positive half cycle and when 0 crossing. So, that becomes equals to this like this, and for he becomes this. So, the common you can say that the end operation you can say that becomes nil, and therefore, you can say that no trip decision in that perspective. Now, coming to this LD and CD, these are you can say that the time shift you can say that the in the time shift LD in this case you can say is being accomplished you can say that for the channel delay CD, agree. So, what happens that when you communicate from this end to this end there is a channel delay. So, that channel delay must be considered taken care. So, therefore, you can say that intentionally you can say that the L and also the corresponding signal is being shifted to the by you can say a time of fixed of LD. We know you can say that tentatively how much you can say that delay will be accomplished to this channel, and therefore, you can say that is about the CD, and according to the CD you can say that the corresponding local signal is also shifted by LD, and that is what being done. Now, if you consider that if the LD and LD equals to CD at the local end, if we that happens to be there, that is the ideal condition, then you can say that the corresponding phase angle information from this coincidence you can say that time can be obtained very accurately. So, when the coincidence time is greater than the TPU we can say that what you say that the time peak of time TPU. So, when the coincidence time that this time coincidence time is greater than the TPU for the internal fault case, the pick up time you can say that timer for pick up, then you can say that based on the SL and SR inputs the relay trips, and if the corresponding the intersection, or you can say the coincidence, you can say the time, this is the coincidence time, the end operation, coincidence time is 0. If that becomes smaller than the TPU, then it is a no trip decision. TDO, you can say that is the time drop, the timer drop time, dropout time, and this is used, you can say, to let the tripping signal, you can say that, for successful tripping and reliable tripping operation and so. So, then we see from this, you can say that phase comparison principle, that the phase information of the current signal is being taken into, you can say that, the rectangular wave, the positive half, you can say that, and then you can say that you can use, you can say that, the corresponding informations, you can say that, by making an ending operation. We know the corresponding coincidence time, that coincidence time is indicative of the corresponding phase angle of the two side signals, and that you can say that the name of the phase comparison protection. In continuing with this phase comparison protections, that the phase comparison protections can include fault detectors, fault detection, including, you can say that, the overcurrent principle or overcurrent principle or so to trigger the corresponding unit, and that you can say will make the corresponding decisions to be more reliable or so. When current becomes higher, then only it should be activated and so, and then you can say that the reliability of, you can say that, the phase comparison can be in a better way. Now, the other aspect of, you can say, is that in the earlier, you can say that examples we demonstrated only that the positive half, many, you can say that applications in that domain relay use also both the halves. So, full wave is being used. In that case, you can say that positive is being compared with the positive and negative half, you can say, is being compared with the negative half, and they are being done independently. So, positive will be compared with positive and negative will be compared with negative half, and the both halves, and that you can say that by that way you can exploit, you can say that, the speed advantage. So, then we do not need to, you can say that, wait for the positive half, you can say that, as you have seen in the earlier example, the negative half also can do, and the coincidence, you can say that, time, you can say that, can be independently processed, you can say that, for the positive half and the negative half, and therefore, you can say that you can obtain the, you can say that, speed advantage for that perspective using the same, you can say that, the timer logic and so what we have already discussed in terms of that. So, the advantage of phase protection, you can say that we require very less informations to be transferred to the other end. So, using, you can say that, conventional technology and narrowband analog signal, you can say that, analog channel signals. So, you can go up to 4 kilohertz or so, you can say that may be adequate for, you can say that one using the voice frequency signal and so. And with today's, you can say that digital transfer, you can say that 64, you can say that, kilobits per second can also, you can say that, can be very successful, you can say that, use the information and so. Some of the disadvantages, you can say that phase comparison schemes are difficult to apply for multi-terminal lines. You remember multi-terminal lines. So, for them, you can say that, comparison of phase, you can say, information of different current signals will be pretty difficult. These schemes do not allow transformers in the differential zone, what we have already addressed. So, because there will be phase shifting and all these things, then you have to put the corresponding delta side to be star connection and star connection to be delta. So, that phase compensation can be accomplished and so. So, those are some of the disadvantages of this perspective, and because of the superior performance of the percentage bias differential relay, which we have already discussed for feeder protection and all these things, application of phase comparison protection is limited today, and the only, you can say that, advantage, you can say that, if the corresponding communication band is narrow, then you can say that we can this, you can say that, phase comparison protections can be better options, and there are already, you can say that, many, you can say that, old, you can say that, applications are there in that perspective. So, still in many systems we can find this, but with the newer, we can say that, digital technology, all these things, this finds a limited scope. Now, example on this. So, we have a 400 kV systems, L and R the two, you can say, ends, and then we have, you can say that, for two cases, external fault case, and this, you can say that, the blue curve, you can say that, is for the Ln, you can say the information, current information, and the green dotted one, you can say that, the Rn, you can say, informations, and there you can say that, because this is an external fault case, they are out of phase, and therefore, the corresponding square wave of the positive half, and then you can say that, here for that one, the overall, you can say that, the coincidence time will be 0 here, and that you can say that the corresponding you can say that fault can be detected easily. Now, in case of you can say that phase to ground fault for the internal fault case, what happens that current is being fed from this side and current is being fed from other side also. These are the two currents you can say that available from the through the CTs you can say that. So, we see here you can say that the current you can say that of the two having a phase difference. This is due to you can say that because the corresponding currents are you can say that due to the non-homogeneity and the line charging current perspective and so, and that makes you consider the corresponding things to be considered some deviation in angle, but note that the phase comparison will still manage because of the coincidence time and related phase angle associated, and that you can say the internal fault can be easily you can say that distinguished you can say that from that perspective. So, with this we say that you can say that line differential protection you can say that is a very reliable you can say that approach unit protection perspective. It requires dedicated communication for that perspective. We also see consider that the line differential protection can be extended with overall line and also transformer. Overall line with also you can say that taped you can say that lines also, multiple tapped lines also can be accomplished you can say that for the line differential perspective. We also see you can say that how phase comparison approach can be also be applied you can say that with communication system arrangement for the line protections. But this line you can say that differential current differential relays also have their own limitation. It is costly compared to distance relay schemes because of the communication and so. In case of communication fails you can say that the method has no answer, it will not work at all unless the other end current information is there. Required synchronization of phasors you can say that for the EHV long lines. So, either of the GPS or the new near technology of you can say that technology or so. Differential relay do not provide any backup. It cannot say about in case of other section of so, that is you can say that one of the important disadvantage of this one. Whereas, in case of you can say that distance relay even with the overcurrent relay we have backup protection arrangement. Distance relays have various backup schemes including zone 3 and so, and that operate you can say that cost of there is no extra cost for it. So, it uses only the local information and that. So, those are you can say the limitation of line differential, but with today's reliable communication facility using the fiber optic or so, current differential is application is by becoming increasing more in numbers. In addition, with the considered communication facility available, combining other relay principle like directional comparison including distance relay applications even during communicational failure also, we can integrate you can say that number of principles you can say that in a same you can say that same you can say that relay module and make the you can say that corresponding decision process more reliable. They complement these principles you can say that complement each other, and therefore, you can say that the accuracy of the precision or the reliability of the protection schemes becomes more enhanced. Thank you.